So this video will be a brief overview of some of the stuff you're going to see in Chapter 2. So Chapter 2 deals with limits. So we want the limit as x approaches some value a of f of x is going to equal some number. So let's look at what this means. So let's first look at in terms of a graph. And let's see, so I want open circle here. And it goes like this. Close dot there. And Alright. So I have this graph. So now we're going to look at in terms of limits. And what are they asking about? So I want the limit as x approaches 1, but from the minus sign. Well, what that means is we want to approach 1, but from numbers that are less than 1. So what that would mean in terms of my graph is that I'm actually coming in on this curve. And we see as we get to 1, my function is heading towards a value of 3. Right? Right? Now, if I do the limit as x approaches 1, but this time from numbers that are greater than 1, now this time I would then be coming in this way, and now my answer is going to be 1. Right? And then lastly, if I just were to ask, what is the limit as x approaches 1? Right? Well, here, the answer is going to be, it does not exist. Because when I come in one way, I'm heading towards 3. I come in the other way, I am heading for 1. So I'm heading towards 2 different values. So the limit at 1 does not exist. But what if I ask this? What is the limit as f of x as, got ahead of myself. Limit as x approaches 3 of f of x, right? So now you'll notice that in this case, if I come in this way, I'm here. And if I come in the other way, I'm coming here. And so my answer here is it's going to be 0. Right? So what if I just had an equation? So let's say if I just had this. What is the limit? So what is the limit as x approaches 3? And we had x squared plus 2x minus 4. Right? Well, here we can just plug in the number. And so if I did that, we'd end up with 3 squared, 2 times 3 minus 4. Okay. And so we would end up here that the answer is going to be 11. Right? So if you can just plug in the value of x and then just get that number. Right? Well, what if I have one that looks like this? What is the limit as x goes to negative 2? Negative 2. Right? And now I have x squared plus 9x plus 14 over x squared plus 5x plus 6. Right? Well, here, now I have x in the denominator. And the question then is, okay, if I plug in that negative 2, is that going to come out to be 0? And if you notice, if I do plug that in, negative 2 squared is 4. 5 times negative 2 is negative 10. And that will be 0. So we got a problem here. But they're both quadratics. And it ends up they can both be factored. This becomes x plus 2, x plus 7. The bottom one becomes x plus 2, x plus 3. And so now the problem term is going to go away. Oh, sorry, I need to correct that. That should have been a 2. Right. So those terms go away, and now I'm left with the x plus 7 over the x plus 3, and so now I can plug in. So I got a minus 2 plus 7 over a minus 2 plus 3. And so this is just going to give us 5. All right. Well, other possibilities. What happens, though, if I end up with something like this? What is the limit of 4x over x minus 1? And I want the limit as x goes to 1. Well, let's see. If I plug in 1, the bottom term is 0. There isn't any factoring I can do, so we have to make a chart and try to see what is going on. So we're going to plug in values for x, and then we're going to calculate what does this come out to be. Okay. So let's first get to numbers that are close to 1, and so let's do these numbers, 1.1, 1.01, and 1.001, and see what we're getting for numbers here. All right. So we get 4.4. So this number will come out to be 44. And then this number comes out to 404. And then this number will come out to be 4,004. Well, let's see. It looks like we're taking off to infinity if we go that way. But now we have to check numbers coming in from the other direction. So now we're going to do 0.9, 0.99, 0.999, and see what kind of numbers we're going to get here. So this comes out to be 36 negative. This comes out to be negative 396. And then if I do the last one, this comes out to be negative 3996. Right? So if I come in the other way, we're heading off to negative infinity. And so in this case, the limit here is, again, does not exist. We're not getting anywhere. Right? But what if we just looked at one-sided limit for this one? So what is the limit as x approaches 1 from numbers that are greater than 1 of 4x over x minus 1? Well, we see that if we do that, this is heading off to infinity. And then if we said, okay, what is the limit as x approaches 1, but from numbers that are less than 1 of 4x over x minus 1, and here we see the answer is negative infinity. Okay. All right. Well, how about limits at infinity? So how about limit at infinity? So what if I had something like this? What is the limit as x goes to negative infinity? And we have 2 plus 10 over x x squared. Right? Yep. So this is going to be 2 plus 10 over negative infinity squared. Okay? But so basically you got 10 divided by an infinitely large number. And so that is basically just going to be 0. And so my limit here will be 2. Okay? We can look at another one. So let's say we now do this one. What is the limit as x goes to infinity of 5 plus sine x over the square root of x? Right? Well, again, this is going to be 5 plus the sine of infinity over the square root of infinity. Remember, sine values only go between 1 and negative 1, right? And so that number is not going to be very big. And of course, the square root of infinity is still going to be basically infinity. And so this is going to be 5 plus 0. And we end up with 5. Other things you're going to see in this chapter is they talk about asymptotes. And so if I have something like this, y equals 4x over x plus 1. And so we see that there is going to be a vertical asymptote because I have that x in the denominator. And that will occur when x plus 1 is equal to 0. And so x is going to be equal to negative 1. It's going to be an asymptote. Okay. So we can look in terms of end behavior and asymptotes. So if we have a rational function, f of x is equal to p of x over q of x. Right? And so p of x is in the form of a sub n m x to the m plus a sub m minus 1 x to the m minus 1 plus so on, so on, so on, and so on. And then the q of x is b sub n x to the n plus b sub n minus 1 x to the n minus 1 and then so on. Right? So we got several possibilities. First case, what happens if m is equal to n? Right? Well, if n equals to m, then the horizontal asymptote occurs at y equals a sub m over b sub n. Right? Next case, if m is greater than n, then there is no horizontal asymptote. Okay. And then the last case would be if m is less than n, then the horizontal asymptote is at y equals 0. Right? And then there is another case they talk about, and that is if m is equal to n plus 1, then there is a slant asymptote. Okay. So let's look at some examples then. So let's say we had this. So y equals 4x to the 5th, 12x cubed minus 7x squared over 9x to the 5th, 14x to the 4th, plus 8x cubed. Right? Well, again, we want the end behavior, so we want to know what happens as x goes to infinity. Well, when x goes to infinity, we said, well, m and n are equal to each other, and so the limit here is going to be given by 4 over 9. Okay? Because when we go to infinity, those other terms don't matter. Okay? All right. So now let's look one in terms of what happens if I have a slant asymptote. So now we look at this one. So y equals 2x cubed, 3x squared, plus 4x plus 1 over x squared plus x. So in order to find the slant asymptote, we have to do some long division here. So we're going to do x squared plus x. We're going to divide that into the 2x cubed, 3x squared, 4x plus 1. Well, let's see. What I got to multiply x squared by in order to get x cubed, and so that number will be, we're going to multiply this by x. So this is going to give me x is going to be, actually should be 2x. Sorry. So 2x times x is going to be 2x cubed plus 2x squared. And then the next step in your long division was you subtracted. So we're going to subtract that. Right? The x cubes go away, and this will be x squared. And then bring down the next term, which is the 4x. And then we have to, now we just have to multiply by 1. So plus 1. And so this will give me x squared plus x. And again, we would subtract. And so now we end up with 4x minus x. We end up with 3x. Bring down the next term. And then, of course, that term now will be my remainder. And so we have a slant asymptote at y equals 2x plus 1. Right. Other terms to talk about is continuity. So about continuity. So basically what that means is f of x has to be defined for all values of a. So whatever number I plug in, I gotta be able to get an answer here, right? Is what that means. So that's the first thing that has to be true. Second thing is that the limit as x approaches a of f of x has to exist. And then the third thing is that the limit as x approaches a of f of x is going to equal f of a. Right? And then continuity on an interval. And so the limit as x approaches a for the minus sign of f of x is going to equal a, and the limit as x approaches a from the positive side of f of x is going to be f of a. Right. Well, let's see, the next term you'll see they talk about is what's the intermediate value theorem. Right. So f is continuous on the interval. Let's correct that. Is continuous on the interval a to b and L is a number between f of a and f of b. Then there exists at least one number C in the interval a to b satisfying that f of c is equal to L. And so let's look at this one. So let's say I have this. We have 2x cubed plus x minus 2 equals 0. Okay? And I have the interval -1 to 1. Okay? Well, let's see. So let's do first. So if x equals -1, well, this is going to be 2 times -1 cubed plus -1 minus 2. And so this is going to give us -5. Right? And then if x is equal to 1, then this is going to be 2 times 1 cubed plus 1 minus 2. And this is going to give us 1. Right? And we said this function is continuous. It's continuous, so then there has to be some number, because we go from -5 to +1. So at some point, some number, we have to cross the x-axis. And so, yes, there has to be a number. Right? So there has to be a value of x such that 2x cubed plus x minus 2 would equal 0. And then if we graph that, we can try to determine what that value is. And then the last thing they talk about in regards to limits is using the precise definition. So we're going to look at this in terms of an example. So what is the limit as x approaches 4 of 4x minus 15 equals 1? Right? So we want to find delta. And here we got that given A is 4 and L is going to be equal to 1. Okay. So we get the absolute value of 4x minus 15 minus 1 is going to equal epsilon. And so the absolute value of 4x minus 16 is going to equal, right? And then we could factor a 4 out. So x minus 4. And then we could divide by 4. And so we know the absolute value of x minus 4 is going to be less than, and I do need to change this. I realize instead of equals, I should have had less than in here. So less than e, sorry. All right. All right. All right. So that's the first part of it. Now we have, let e be greater than 0. So 0 less than rx minus 4, which is less than delta. And so delta is going to equal e over 4. So 4x minus 15 minus 1 is going to equal 4x minus 16, which is going to be 4 x minus 4. Which is going to equal 4 e over 4. And so, all right, which is going to be less than e, right? And so f of x minus L is going to be 4x minus 15 minus 1 is less than epsilon. And this is whenever 0 is less than 4x minus x minus 4 less than or equal to epsilon over 4. Provided that 0 is less than delta, which is less than or equal to e over 4. And so therefore, the limit as x approaches 4 of 4x minus 15 is indeed equal to 1. Okay? And that will conclude this video.